22. Okay, very good. The function is it's k, I think. I think I see. Yes, it's k, 1 over the square root of x. I'm going to change this into x to negative 1/2. It's easier to differentiate. Okay, in part A, they want us to find the linearization, L of x, of this function at a equals 4. Anyone would like to help? How do I start? What is the formula? L of x, the linearization, will give us the equation of the tangent line to the graph of this function at point 4. Anyone? Quinn, have you been paying attention?
Is it 0.5?
So we have f of a, I'm sorry, k of a. I'm going to change this into f of x, sorry. So f of a plus f prime of a times x minus a. Good. So when we plug in 4 here, or 4 here, to get f of a, can anyone give us f of a?
Is it 0.5?
Yes, 1/2, very good. So now let's find the derivative. So obviously this is x minus 4, but we want to find the other piece, which is f prime of a. But first I have to find f prime of x. So f prime of x will be, bring down negative 1/2, x to negative 1/2 minus 1, which is negative 1 over 2, the square root of x to the 3rd. Ugly, but that's what it is. So now we're going to plug in 4. So f prime of 4, negative 1 over 2. This is the square root of 64. The square root of 64 is 8. So this is negative 1 over 16. So this piece is negative 1 over 16. Let's take a moment and think for a moment or two. Tell me if you need anything. Is this okay?
Could you find the derivative of the x to the negative 1/2? Okay. Thank you.
You want me to do this again?
No, I just want to make sure I was pulling the right information.
Yes. So I had to change this into x to negative 1/2. I brought down a negative 1/2 and I subtracted 1 from the power. Then it was easier for me to evaluate this by replacing this by this first. So this is the square root of x to the 3rd in the denominator. So when I plug in 4 here, 4 to the 3rd is 64. The square root of 64 is 8. 2 times 8 is 16. And the minus in front. So now this piece is 1/2. This piece is negative 1 over 16. And this is x minus 4. Everyone in agreement with this so far? Marcus, are you with us? Jeremy? Is anybody here other than?
Yeah.
Okay. Good. So then the linearization. L of x equals 1/2 minus 1 over 16 and x minus 4. Yes, I have to simplify. I have to combine like terms, etc., etc. So this is negative 1 over 16x. When I multiply 4 over 16, I get 1/4 and plus 1/2. This is positive and this is positive. Okay. So then L of x, negative 1 over 16x, and this one needs a 2, so this is plus 3/4. And this is it. And this is part A. Now part B. Let's see what they want. Any questions on part A? Okay. Part B. What is part B? Use the linearization to approximate 1 over the square root of 3. How much is x in part B? Can anyone give us x?
1 over the square root of 3.
Careful. We are
Or would it
looking,
be the square root of 3.
so we are comparing this to this. And we have to find x.
3.
Yes, very good. So we have to find L of 3. So I have negative 1 over 16 multiplied by 3 and plus 3/4. And I got 0.241071428 and I'm pretty sure they want us to determine this now. I wrote 3 over 7 instead of 3 over 4 right here. Why? Don't ask me. Okay, so my L of 3 was wrong. So 0.5625 and 1 over and f of 3 equals 0.57735. Okay, so this is probably, most probably, we didn't get there, but find 1 over the square root of 3, which we did with the graphing calculator. So that was it. 1 over the square root of 3 is 0.577, and our calculations using the line, negative 1 over 16 times 3 plus 3/4 is this. For some reason, I put 7 instead of 3/4 here. That's why that was the error. Okay, so we are comparing these two. Allow me 1 second to make sure that I don't forget to eliminate the error. Okay. And now probably they're going to ask us to determine the difference. What is the difference between the approximation and the actual value? Okay, fine. So the approximation was this. So I'm going to subtract from it 1 over the square root of 3. And the difference is, so that's part D. The difference is a negative 0.01485. If you can live with this error, then you can use the linearization to evaluate the original function at 3. If you cannot live with this error, and you say, no, 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 it's huge, then you have to evaluate the function. I think the error is acceptable. Good. Are we okay now with linearization?
How did you get for B? How did you get the X for 3 again?
You mean on you mean here? Approximate, use a linearization to approximate 1 over the square root of 3?
Oh, wait, yeah. Oh, my bad.
So no, that's okay. It's okay. Any question is perfect. So you have to find x. And if you compare 1 over the square root of x to 1 over the square root of 3, you realize that x must be 3. Because this replaces the function. L of x replaces 1 over the square root of x. So x is 3. We have to be close to 4. So the linearization works only close to 4. 3 is quite far away. but that's what they're giving us. The linearization works very close to 4. The error will be very minimal as long as we have x close to 4. 3, the distance between 3 and 4 is huge. On the previous example, we were looking at 16. 17 is somewhat acceptable. But from 3 to 4, that's why the error in this case is a little bit bigger than before, because we are quite far away from 4. 3 is not close to 4. But 17 is close to 16. That's why the error in the first example was much smaller. The same thing here. We are comparing the square of x with the square of 17, which told us that x is 17, which is close to 16. 3, not too close to 4. Very good question. Anything else? Other questions here? Okay, I would like to go back to the title, and the title was marginals and differentials. So we talked about the linearization. Now I would like to talk about marginals, and then we're going to talk about differentials. So we did talk about marginals before. This is not new. So what is the marginal? Well, marginal cost, revenue, profit. What are those? Well, C prime of x, R prime of x, P prime of x. So this is not new. So these are functions. They are called they're the derivatives of the cost, revenue, and profit, but they also have the name of marginal cost, marginal revenue, marginal profit. So this is nothing new. So let's look at a problem. Marginal revenue, cost, and profit. Is this okay?
Yeah.
Okay, perfect. Let's take a look. Nothing new so far. Just a minor interpretation that I need to explain. So 25, and that is on page 341. So they're giving us everything. R of x equals 50x minus 0.5x squared. They're giving us C of x 4x plus 10. And they want us to find part A, P of x. Fine. No problem in part A. Oops. P of x equals R of x minus cost of x. So then P of x equals 50x minus 0.5x squared minus 4x and minus 10. And in the correct order, negative 0.5x squared, 50 minus 4, 46x, and minus 10. So this is the profit function. Okay, let's look at part B. R of 20, C of 20, P of 20. Okay. R of 20, C of 20, P of 20. Part C, and we'll do that in a minute. Let's find R prime, C prime, and P prime, because they want us to determine R prime of 20 and so on and so forth. So we're going to come back to the calculations. So R prime of x, 50 minus x. C prime of x is 4. And P prime of x is negative x plus 46. In part D, they want us to find R prime of 20, C prime of 20, and P prime of 20. Okay. So the graphing calculator, let me share first. Okay. in y equals. Clear. I'm going to enter r of x first. 50x minus 0.5 x squared. Okay, I am also going to enter r prime of x, which is 50 minus x. And when I enter 20, I get both at the same time. So 800, the first one. We're going to talk about the measurement unit in a minute. And 30, okay, back to r equals. Okay, now I want to put in the cost for x plus 10. And 4, it's very clear there is nothing I can do about that. So just 20 is 90. Good. And the last one, I don't need to really, let me stop sharing here. So the profit has to be revenue minus cost. So 800 minus 90 is 710. The same thing here. R prime minus C prime will give us P prime. So this is 26. So now, measurement unit. Let's go back. We need the measurement unit for everything. Okay, it says in dollars from the and X items. So this must be dollars. But what is the measurement unit for revenue, marginal cost, marginal profit? What is the measurement unit for these three, please? Measurement unit, please, for the rate of change of revenue, cost, and profit when X is 20. Please, anybody, the measurement unit for the rate of change? Can anyone give us the measurement unit for 34 and 26? Anybody remembers the measurement unit for the rate of change? Anybody, please? Lauren, what do you think?
I would just say units, but I'm not sure.
It's a rate of change, so it's dollars per unit. Dollars per unit. The rate of change, like speed, miles per hour. So we also have another question here, and it says explain what each quantity in parts B and D represents. Okay, so here the revenue when we manufacture 20 units is this. The cost when we manufacture 20 units is this. The profit is this. From the revenue we subtract the cost and we get a profit. Now, this is very important. What does $30 per unit represent? Well, this represents, it predicts the revenue for the 21st unit. What does this represent? It predicts the cost of the 21st unit. I'm going to write this for you in a minute. And what does this represent? It predicts the profit on the 21st unit. So all these predict the revenue, cost, profit, respectively, for the 21st unit. Again, it predicts, they predict, all these numbers predict the revenue, cost of the 20 and the profit, approximate, of course, revenue of the 20 revenue, cost, and profit of the 21st unit. Okay, any questions about marginals? That's basically all I had to say. If we need other examples, we can look at other examples. If not, we will look at differentials. Anybody, please?
We look at one more example.
Yes, very good. Good. We cannot do this 27 just yet because I did not talk about differentials yet. So these problems will come into play when we finish talking about differentials. So yes, all these include the differentials that I haven't discussed yet. Okay. So let's continue. I know we have 9 minutes. No, what is it? 11 minutes, 10 minutes left. I'm going to try to finish the marginals. I may or may not be able to finish in 10 minutes. Okay. Differentials. Okay, a fancy word, differentials. What does it mean? Okay. Again, let's go back to our function. And let's say I have here a point. That's point P. And of course, the tangent at P. I need the tangent at P. Here it is. Okay. I also have a point here, Q. And I'm just going to put everything in a coordinate system. And the coordinates of P are x, and I know you're going to say f of x, and Q, the coordinates of Q, the coordinates of Q will be x. So this is something called delta x or dx. So obviously Q will have the x coordinate x plus dx or x plus delta x. So what are all these notations, first of all? So dx is something called the differential of x. Anything that has differential in it, you know it's coming from a derivative. Differential. Differentiable. So it's coming from a derivative. So that's why the notation dx. Dx is the differential of x. What does it really mean? Well, it's this tiny error, if you want, tiny difference, small difference between point P and point Q. They are very close to each other, but I have to zoom in so I can explain what I'm doing. What are we trying to get to here? So this is a small difference. But remember, because of the notation and because it's called differential of x, it has something to do with the derivative. Now, what about this delta x? What is this delta x? They are the same. It's also a small difference, right? It's equal to dx. It's a small difference, but this is called delta x. This is the uppercase delta. This is the smaller case delta. We don't use this in this class. I do in other classes. Okay, so delta x has nothing to do with the derivative because it doesn't have d in front because it has delta. And this is the actual difference in x. It happens that is the same with dx. Dx is the differential, delta x is the actual difference between these two x values, the x value of p and the x value of q. Okay, now what will be the y coordinate of q? That will be f of x plus dx or f of x plus delta x, because dx and delta x are the same. Okay, fine. So now we learned what the differential is. Of x. So we know what the dx is, and we know what delta x is. Okay, now notice something very interesting. A small change in the x value triggers a difference in the y value. So this is the difference in x. Imagine that I produce discs of metal, and I have a small error, delta x, in the radius. What will that happen? What will that do? Will change the area, will create an error in the area of the disk. So if I have a minor error in the radius, that will trigger an error in the area, in the function, which is the area of the disk, because I have an error in the radius. So the same thing here. I have a distance, a small distance between point P and point Q on the x-axis, but that will trigger a distance or a difference in the function values. And what will this be? This is the actual delta y, the actual difference created by this error or this distance or this change in x triggers delta y. What is delta y? Delta y is the actual difference created, delta y actual difference in the function, in the f of x, created by delta x. What does it equal to? Delta y is f of x plus delta x minus f of x, this distance. So f of x plus delta x minus f of x. Okay, so we established what dx is, we established what delta x is, we established what delta y is. What do you think is left? Is anyone with me? Anyone paying attention? So we have dx, we have delta x. We found delta y. What do you think follows next?
E of y?
Exactly. And that will be dy is the differential, not the derivative. Differential of y. Okay. Or f of x. Okay. Let's see what this is. Okay. Since it has d in it, and it's called differential, it has to involve the derivative. So here it is. That's why I extended this line to meet the tangent. This is dy. How do I know that? Because this is dx, and this, the slope of this line, you already told me on the previous problem, the slope of this line is f prime of x. That's the slope. And the slope is rise over run. And the other notation of f prime is dy over dx. So I'm going to redo this on Thursday. Dy equals f prime of x. Sorry, what I wanted to write is that f prime of x equals dy over dx. Therefore, dy equals f prime of x dx. And that's not what I wanted to write. I wanted to write f prime of x, as I mentioned, is rise over run, the slope of this line, rise over run. F prime of x is dy over dx. And when we cross multiply, we get the dy equals f prime of x dx. So I will explain this again, all these four quantities, dy, dx, delta x, and delta y on Thursday, and then we'll practice.